Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is OCR November 2021, paper 6, higher tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below, as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends, because they might need a helping hand too. Okay, let's get into it. Question 1. This table shows the names and areas of 5 lakes. Well, not heard of many of these. Lagoda, Muero, Tana, Topozero, Victoria. Part A says write the area of Lake Muero as an ordinary number. So here's Lake Muero, and you can see that in standard form, you can see its area is 5.12 times 10 to the 3. Okay, so converting that into a normal number, you've got standard form power 3 here, which means I can either multiply it through by a 1 followed by 3 zeros, or I can just shift the decimal point 3 jumps to the right, can't I? So 1, 2, 3. So it's going to be 5, 1, 2 and an extra 0 then on the end. Okay, so that's 5,120. Part B says write the lakes in order of their area, starting with the smallest. Okay, well the one which is the smallest is going to be the one with the lowest power, isn't it? Because that is going to be the smallest magnitude. So this one here with the 2, that is going to be the smallest. So Topo 0 is the smallest. Okay, next power of 10 up is 3. So 10 to the 2 is hundreds, isn't it? And 10 to the 3 is in the thousands. So both of these lakes have areas in the thousands. Now, obviously, 3,000 is less than 5,000. So Tana is going to be the next smallest, and then Muero, because 3.2 is less than 5.12, isn't it? Muero. Okay, and then I've got 2 lakes whose areas of the magnitude 10 to the 4, which is in tens of thousands of square kilometers, isn't it? So out of Lagoda and Victoria, you can see Lagoda's got 1.81 and Victoria's got 6.89. So Lagoda is the smaller of the 2 and Victoria is the largest. Ladoga next, and then Victoria. Okay. Part C says calculate the difference between the areas of Lake Ladoga and Lake Tana. Give your answer in standard form correct to 2 significant figures. Okay. So difference in mathematics means subtract, isn't it? So we need to take one away from the other. So we are going to be taking the smaller one away from the bigger one, aren't we? So which one's smaller? Ladoga and Tana. Tana is the smallest because it's 10 to the 3. And Ladoga is 10 to the 4. So I'm going to take the smaller one away from the bigger one. So that's going to be 1.81 times 10 to the 4 subtract 3.2 times 10 to the 3. Okay. Now, It's a bit hard to subtract numbers when you've got these powers, different powers on the end. But if I take a power of 10 out of 10 to the 4, so if I take 10 out of 10 to the 4 and leave it as 10 to the 3, and with that 10 I can multiply the mantissa part of the number and get 18.1 times 10 to the 3. So I've kind of taken a 10 out of the power and stuck it in with the mantissa at the front. Then I've got 18.1 times 10 to the 3 minus 3.2 times 10 to the 3. Now these two are now of the same magnitude, so I can go ahead and I can subtract the mantissa parts from each other. So 18.1 subtract 3.2. Well, 18 take away 3 is 15, and 15.1 take away 0.2 is going to be 14.9, isn't it? So that's equal to 14.9 times 10 to the 3. Okay. Now I'm going to take the 10 back out of the 14 and put it back in with the 10 to the 3. So that's going to be 1.49 times 10 to the 4. Final answer does ask for two significant figures though, so I'm going to round this off and say that is 1.5 times 10 to the 4 as the final answer. Question 2. Asmi, Beth and Callum share a flat. Part A says the monthly rent is £760 and they share the rent in a ratio of 2 to 3 to 3. How much does Beth pay for rent each month? Okay, so presumably that's in order then. So A to B to C, Asmi to Beth to Callum is in a ratio of 2 to 3 to 3, isn't it? Okay. Now, basically here what we're doing here is dividing by a ratio, isn't it? Because we want to know what Beth pays. So if you add the parts together, 2 plus 3 plus 3, that means we have a total of 6 parts altogether, haven't we? 2 parts for Asmi, 3 parts for Beth, 3 parts for Callum, 8 altogether. Now dividing the £760 into those 8 parts, so 760 divided by 8, what's that then? Need my calculator. 760 divided by 8, that comes out to be 95. So that means each share is worth 95. Okay, and then so to find what Beth has, we're going to take our ratio 2 to 3 to 3. We're going to scale it up by a factor of 95 then, aren't I? So Asmi's going to get 2 lots of 95. That's 190. Beth's going to get 3 lots of 95. Well, she'll have to pay 3 lots of 95. That's 285. And the same for Callum, 285. Now at this stage you might want to just double check your work by adding the 285 and the 285 and the 190 together. Just double check they come to 760. Mine do. So then Beth's then is that one in the middle, is 285. Okay, so how much does Beth pay? Beth pays 285 squids. Okay. Part B says Asmi, Beth and Callum also share the fuel bill in the ratio of 2 to 3 to 3. Callum pays £36 for fuel each month. How much does Asmi pay for fuel each month? Okay, so again we've got the ratio for Asmi, Beth, Callum, and they're in a ratio of 2 to 3 to 3. And we're saying that Callum gets paid, or pays £36 for the fuel. What do the other parts then have to pay? Well, Beth is the same as Callum, isn't it? So that's going to be 36 as well. What about Asmi? Well, if you have a look at what you have to multiply 3 by to get 36, 3 times 12 is 36, isn't it? So that's been scaled up by a factor of 12. So if I scale up this side as well by a factor of 12, then 2 times 12, that's 24. Okay. And so how much does Asmi pay for the fuel? That's that one there, isn't it, Asmi? So Asmi pays £24. Okay. Question 3, multiply out and simplify 3 lots of x plus 2 minus x minus 1. Okay. Well, the first bracket is fairly straightforward, isn't it? I just need to multiply everything in it by 3. So 3 times x, that's 3x, plus 3 times 2, that's 6. Now take care with the second bracket, because actually you've got like an invisible minus 1 in front of there. You have to actually times everything in the bracket by minus 1. So you've got minus 1 lots of x, which gives you minus x. and -1 times -1, that's actually +1. So the sign on the last term is going to be flipped around like that, and that's going to catch quite a few people out, I think. Yeah, so it's 3x plus 6 minus x plus 1. Now all we have to do is collect like terms. We've got 2 terms in x, and we've got 2 numbers. So 3x take away x, that's 2x, and 6 plus 1, that's 7. So 2x plus 7 is the final answer. So like I say, the thing that puzzles or throws most students is that minus x minus 1, and remembering to times the 2 negatives together to give you a positive. Question 4. Triangle A and triangle B are drawn on a coordinate grid. Part A says reflect triangle A in the line x is 0. Just take care here, x equals 0 is not the x-axis, is it? X equals 0 is actually the y-axis. This line here, that's our mirror line. Okay, so this point on the tip of the triangle of A is already on the mirror line, so it's 0 squares away, so it's going to stay invariant, isn't it? It's not going to move. The other 2 points are 1, 2, 3, 4, 5, 6, 7, 8 points away, 8 squares away, so they're going to be reflected, and they're going to be 8 squares on the other side of the mirror line, so they're going to be here at -8, 6, and at -8, 2. Okay, so once I've got my points, I reflect the points, not the lines. If you try and reflect the lines, you're going to mess up. So work out where the points go, and then join your lines, your points together with lines. Okay, it's the easiest way of doing it. Okay, I'm just going to label that A dash, the image of A. Okay, and then describe fully the single transformation that maps triangle A onto triangle B. So this is clearly an enlargement. Well, we call it enlargement in maths, but actually you can see it's shrunk. So it's a reduction really, isn't it? But we still call it an enlargement in the magical mathematical world. So yeah, it's enlargement with a fractional scale factor. So in order to describe this transformation fully, we need to know 2 things about it. We need to know the scale factor, what fraction it's been reduced by, and we also need to know the center of enlargement. Okay. So first up, the scale factor. If you count the distance along this line here, look, that is 1, 2, 3, 4, 5, 6, 7, 8 squares, isn't it? That's 8 squares. Where it's matching one on the image is equal 1 down here. That's only 2. Okay, so it's gone from 8 units to 2 units. In other words, it's a quarter of the size it used to be. You could do that with any other sides as well. So it would give you the same fraction. Okay, so if I'm going to describe this, I'm going to say it's an enlargement with scale factor of 1/4, and now I just need to find the center of enlargement. So where is the center of enlargement? Well, I can do that by using my ruler and drawing on some array lines. What I do is I find matching points on object and image, and I'm going to draw some lines through them. Okay, now these lines should converge on the center of enlargement. I can already see where it is actually, but I'm just going to show you a little bit more. So another line going through here, and remember I've got 2 points on the y-axis here, so the y-axis is a kind of array line as well. Okay, so you could have a ray line going that way as well. And anyway, you can see all of these lines converge on this point here, don't they? Which is 0, -6. So that is going to be the center of enlargement, isn't it? So that's going to be at 0, -6. Okay. So note this is a 3-mark question, isn't it? And you get 3 marks, 1 for enlargement, 1 for the scale factor, 1 for the center. Okay. So make sure you get all those 3 bits written down. Question 5. Ling throws a 6-sided dice 300 times. The table shows the frequency of their results. Complete the table to show the relative frequencies. Okay. So we've got 1 done already. We already know that the relative frequency for 3 is 0.19. Now you're going to get the relative frequencies by, well, let's just give the formula. Relative frequency is equal to successful trials over total trials. Okay, So here, total trials is 300, isn't it? So the total trials here is the number of throws altogether. And the successful trials, well, that's just, you know, the number of successes for that particular number. So for 3, there were 57 successes. And you'll see if you divide 57 by 300, the total number of trials, you're going to get 0.19. Yes, you do. Okay, so let's just do that with the others. We're just going to divide each one by 300. So 42 divided by 300, that is 0.14. Okay, 27 divided by 300, that is 0.109. 60 divided by 300, that is 0.2. 39 divided by 300 comes to 0.13. And 75 divided by 300, that comes to 0.25. Okay. Ling thinks the dice may be biased. Explain why evidence from the table could support their opinion. Okay, well, clearly you've got quite a bit of variation here, haven't you? So if you have a look at the number 2, that has come up 0.09 times. And compare that to the 6 over here, which has come up 0.25 times, which is, that's almost 3 times as often, isn't it, actually, if you think about it. So 0.9 times 3 would be 0.27, so there or thereabouts. Okay, so that's going to be my evidence. So the relative frequency of 6 is 0.25 compared to rel freq of 2, which is 0.09. This is almost 3 times as much. Okay. Right. Then part 2 says, explain why the dice may in fact not be biased. Well, there isn't that many trials here, is it? 300, and sometimes you get a lucky run, don't you? So I'm going to say there is a small number of trials, and you should expect some variation. Question 6. A bag of sweets contains jellies, mints and toffees. The ratio of jellies to mints is n to 2. The ratio of mints to toffees is 5 to 3n. Work out the ratio of jellies to toffees. Give your answer in its simplest form. Okay, so we've got 2 ratios here. They're partially algebraic. So I think the first step is to try and kind of bring the 2 things together and kind of form them into one ratio. Okay, so we've got jellies and we've got mints and we've got toffees. Okay, we know that the ratio of jellies to mints is n to 2, and we know that the ratio of mints to toffees is 5 to 3n. Okay, now I think what we want to do is try and combine those together. Okay, now the way to do that is to find like a common denominator, or a common multiple of these 2 numbers here, 2 and 5 in the middle. So if we can kind of scale these up so they're both like some same multiple of these, then we can kind of make one ratio. Okay, so the common multiple of 2 and 5, that's going to be 10, isn't it? So if we can make this ratio into 10, then we can bring down the other parts and kind of form one ratio then. So let's take this first ratio, n to 2. Now to scale that up so that the mints is 10, I would need to multiply through by 5, wouldn't I? So doing that to the n as well, I'd get 5n to 10 is the equivalent ratio, isn't it? Okay, and then on the other side, 5 to 3n. If I want to make it 10, I'm going to have to double it up, aren't I? I'm going to times that by 2. So 5 times 2 is 10. I've already got that written down. 3n times 2, that's going to give me 6n. So I've got 5n to 10 to 6n. And then it says work out the ratio of jellies to toffees. So we want to compare this one then, the jellies, with this one, the toffees. Okay, so this is in a ratio. So jellies to toffees, that's going to be in the ratio now of 5n to 6n, isn't it? Okay, and then all I need to do now is divide both ratios by n. Okay, so then we can see that then these are going to be in the ratio of 5 to 6. Okay, so 5 to 6 is my final answer. Question 7. The scale drawing represents a park ABCD and the scale of 1 centimetre represents 10 metres. A straight path goes across the park from B. The path is always the same distance from the side A and side B. And part A says construct the route followed by the path. Show all the construction lines. Now a path that's always the same distance from two sides, A, B and BC, that's going to be the angle bisector of ABC then, isn't it? So I'm going to have to use a pair of compasses here to make this construction. So when you're using a pair of compasses, make sure that you're using a short pencil so you can twirl it around without bumping into your fingers. Also make sure that the tip of the pencil and the compass, tip of the compass are in the same place. Once you've got that sorted, we're ready to do the construction. So putting the point of the compass at B, we're going to draw an arc that crosses both arms of that angle then, AB and BC. Okay, once we've got that drawn, I'm going to move the tip of the compass to the point on AB where the arc crossed. And we're going to draw a second arc between the arms of the angle. And then over to BC, and where the arc crossed, we're going to do that again and draw another arc there. And you'll see that you get like a little cross in between the two lines. Okay. Now what we're going to do then is put a ruler and line it up through B and then through the center of that cross we made from the two arcs. And we're going to draw our line here. Now this line is going to be the angle bisector of ABC. And you should see that it cuts that angle exactly in half. So that is going to be my path that I need to draw. Okay, now part B says a bench is to be placed on the path. The bench must be no more than 50 meters from C. Construct the locus of possible positions of the bench. Indicate clearly on the diagram where the bench can be placed. Okay, now we've got another construction to draw here. This time we're going to be drawing a circle centered on C with a radius of 50 meters. Now obviously I can't draw a 50 meter circle, but the scale of this is 1 centimeter representing 10 meters. So taking our ruler and our compass, let's just set the aperture of the compass to exactly 5 centimeters. Okay, from tip to pencil tip. And then we're going to draw a part of a circle centered on C. Okay, now you see that arc crossed the line I drew earlier in two places. So let's just mark those a little bit more clearly. Now it says that the bench needs to be less than 50 meters from C. So basically it can be anywhere between these 2 points. So anywhere between these two is acceptable. So just to make it nice and clear, I'm just going to write on here bench between these points. Okay, so it doesn't just have to be at the end points, it can be anywhere between those two crosses. Question 8a. Train A travels 120 kilometers at a constant speed of 80 kilometers per hour. Train B travels 120 kilometers at a constant speed of 50 kilometers per hour. How many more minutes does train B take to travel to 120 kilometers than train A? Okay, so I'm going to use a distance, speed, time triangle here, DST. So this is going to be train A. Let's do train A first. So train A, distance, speed, time, what's what? Distance is 120 kilometers, isn't it? Okay, that's there. And then I know speed is 80. Okay, so speed is 80 kilometers per hour. So what we want then is time, isn't it? That's the one we're trying to find. So cover up T, and that tells me, the triangle tells me what to do with the other two. So it's going to be time equals distance divided by speed, okay, which is distance 120 divided by speed, which is 80. What's that? That is 120 divided by 80. That's 1.5, isn't it? 1.5. That's going to be in hours, isn't it? 1.5 hours, that's 1.5 hours. That is 90 minutes, isn't it? Okay. Remember, the answer needs to be in minutes, so yeah, I'm going to convert into minutes. Let's now look on at train B. Do the same thing. Train B, same thing. Distance, speed, time triangle. DST. Distance is still 120 kilometers. Speed this time has been reduced, isn't it? It's now 50. So that's 50 kilometers per hour. And we're still finding time. So it's still going to be time is equal to distance divided by speed. Which this time is 120 over 50. What's that then? 120 divided by 50, that comes out to be 2.4. Okay, now what is that in minutes? Well, if I press the little circle dash double dash button, can you see that converts in 2 hours and 24 minutes? Okay, so 2 hours and 24 minutes, that is 60, 60 and 24, 120, 144 minutes, isn't it? Could just times it by 60, I suppose. That would have been easier. So anyway, I've got 90 minutes and 144 minutes. So how many more minutes does train B take? Difference is going to be 144 minus 90. Just get into the habit of writing down anything that you type into your calculator. It's good practice. If you make a mistake with your calculator, you're still going to get the marks for method. So difference is 54 minutes, and that's my answer then, isn't it? Part B says train C has a speed of x kilometers per hour. Write an algebraic expression for train C's speed in meters per second. Okay, so I've got in kilometers per hour, it's equal to x, isn't it? Okay, now if I want to change to meters per hour, I would have to multiply by 1,000, wouldn't I? So that is equal to 1,000 x meters per hour. Okay, and then if I want to convert it into meters per minute, then I'm going to have to divide by 60, aren't I? Because there are 60 minutes in an hour. And it's obviously going to be doing fewer meters in a minute compared to in an hour. So I'm going to divide by 60. And then to go from meters per minute to meters per second, I'm going to divide by another 60, aren't I? So it's actually going to be 1,000x over 60 times 60. Okay, so what's that? That's 1,000 over 360. So that's 1,000 over 360x. I could cancel that with that. Can I cancel that down any further? Just type it into the calculator. It will cancel it down for me. That comes out to be 25 over 9. So I'm just going to write that as 25x over 9. That's my final answer. Question 9. The width W of a kitchen cupboard is 60 centimeters. Correct to the nearest centimeter. Part A says complete the error interval for the width W. Okay. Now, it's correct to the nearest centimetre. So if you had like a ruler that you measured it with, then like 60 would be there. The next unit above it would be 61, and the one below it would be 59. Okay, and if you decided it was 60, it must have been halfway between or nearer then this kind of range in here. Okay, what's halfway between 59 and 60? That's 59.5. What's halfway between 60 and 61? That is 60.5. Okay, and then so the error interval is going to be, just notice these signs have gone a bit weird when I printed it. Let's just write those properly when I'm doing it, because it looks odd. So then that's going to be 59.5 is less than or equal to W, which is less than 60.5. Now you might say 6.5 rounds up to 61. It does, but it still marks the boundary between where it starts and stops rounding off. So it's the one we use. Right, 6 of these kitchen cupboards are to be placed side by side along a kitchen wall. The wall is 363 centimeters long, correct to the nearest centimeter. Show that the 6 cupboards may not fit along the wall. Okay, well, they might not fit along the wall if we use the smallest possible length of the kitchen wall with the largest possible size of the kitchen cupboards. So that's what I'm going to look at, I think. So anyway, let's have a look at first off the wall length. So the wall is 363 centimeters to the nearest centimeter. So if I was measuring it on a scale, then the one below it would be 362 and the one above it would be 364, and the ones that would round to 363 are the ones that are halfway between or closer. Okay, so that in this case is going to be 362.5, so that's the lower limit, and 363.5 for the upper limit. Okay, now clearly if I take the upper limit of my cupboards, let's find largest possible cupboard width is going to be the 6 cupboards multiplied by the upper bound for each cupboard, which is 60.5. So that means the cupboards could be as much as 6 times 60.5, or just a smidgen under. That comes out to be 363. Okay, and then if we then compare that with the smallest possible size of the wall, which is 362.5, then we can see that one is bigger than the other, and it might not actually fit. So the smallest possible wall length equals 362.5, and because 363 is greater than 362, so cupboards may not fit. So it's may not fit, not definitely won't fit. Depends, doesn't it? It depends if all those cupboards are at the upper end of the scale, and the wall is at the lower end of the scale. Then yeah, there's a possibility that they won't fit. Okay. Part 2 says find the upper bound of the space remaining if the cupboards do fit along the wall. Okay, so the upper bound then is going to be the most space that is extra. Okay, and now this time we're going to take the largest possible wall length, which is going to be the upper bound, isn't it, which is 363.5. okay, and we're going to take the smallest possible cupboard length, which is now this time going to be 6 lots of the lower bound of 59.5. That comes out to be so 6 times 59.5, That comes out to be 357 this time. Okay, so then largest space remaining is going to be those things subtracted, then, isn't it? 363.5 minus the 357, which comes to, what, 6.5 centimeters? So that's my final answer, 6.5 centimeters. Question 10, an equilateral triangle, a regular 10-sided polygon, and another regular polygon meet at a point. Part A says, show angle A is 156 degrees. Okay. Right, so we don't know the size of this other regular polygon yet, but we do know that's an equilateral triangle. So I know that angle there then at the top, that's going to be a third of 180 degrees. It's going to be 60 degrees. Okay, what about this one here? For a 10-sided polygon, this angle there then is going to be, well, the formula is n minus 2 times 180, isn't it? Divided then by the number of sides, and that will give you one of them. Okay, so for the 10-sided ones, that's going to be 10 take away 2, 8 lots of 180 divided by 10, and that is equal to, so 8 times 180 divided by 10, that comes out to be 144. Okay, so that means that angle there is 144. Okay, so what's A then? Well, you can see all three angles meet at a point, and we know that three angles meeting at a point add up to 360 degrees. So we can say that A plus 60 plus 144, that equals 360 degrees. Okay, so just adding these two together, I'm going to get A plus 204 equals 360, and then subtracting 204 from both sides. They're going to cancel. It's going to leave me with A, which is 360 minus 204. That is 156 then, isn't it? Okay, so then A is 156. So then how many sides has it got? Okay, so I've showed the angle is 156. That's done. Okay, so that is done. Work out the number of sides of the other regular polygon. Well, the other regular polygon, if it's got a an interior angle of 156, then exterior angle is going to be 180 minus 156, then, isn't it? 180 minus 156 would be 24 degrees. Okay, and then remember, exterior angle of a polygon is 360 divided by the number of sides. Therefore, 360 divided by n must be equal to 24. Rearranging that, cross multiplying, n goes up, 24 goes down. I'm going to get 360 over 24 is equal to n. So what is 360 divided by 24? 360 divided by 24, that's 15. So n must have 15 sides. So n is 15. Okay. Now you could have used the interior angle formula again. You could have done, but it's just slightly harder. It's much easier just to switch into the exterior angle and then use the more simple formula for finding n. Okay, that's my advice anyway. Question 11. In a class of 30 students, 17 study French, 20 study German, 2 do not study either subject. Complete the Venn diagram. Okay, well the 2's already on there, isn't it? I can see it down there. So that one's already been done. We need to put in the French and German students. Now the problem here is we don't know how many are in the overlap. Okay, so I'm going to start off by saying in the overlap there are X students. So then if there are 17 students studying French altogether, then there must be 17 minus X studying French only. And if there are 20 students studying German and X study both, there must be 20 minus X studying German only. Okay? So now we've got an expression in each of the 4 regions of our Venn diagram. We can equate that with the total number of students in the class. We know there are 30 altogether. Okay, so doing a little bit of algebra, we can say that the number in the first zone, 17 minus x, plus the x plus the 20 minus x plus the 2, so they're the things in all 4 regions, added together must be equal to the 30 students we've got all together. Okay, so then it's just a matter of collecting like terms and solving for x then, isn't it? So I've got like 17, 20 and 2, so that adds up to 22, 32, 39, so I've got 39. Okay, and then for x I've got minus x, x and minus x, that adds up to minus x. Okay, and then that is equal to 30. Okay, I don't like the fact I've got a minus x there. I'm going to add x to both sides so it disappears from there being negative and re-emerges on the other side being positive. Okay, and then I can subtract 30 from both sides, and that will cancel there and there, leaving me with x on the right, and 39 take away 30 is 9. Okay, so now I know that x is 9, I can fill that in the middle, and then I can work out what the other 2 must have been then. So 17 minus x, 17 minus 9, that leaves me 8 there who studied French only, and 20 minus 9 is 11. And if you double check, you should find that all those numbers add up to 30. 8, 9 is 17 plus 11 is 28 plus 2 is 30, so it all works. Okay? Alright, and then part B says 2 of the 30 students are chosen at random. Calculate the probability that one of these 2 students studies French but not German, and the other studies German but not French. You must show you're working. Okay, I need more space. Okay, let's see if I can leave the Venn diagram up, but show enough space. 5 marks for this, so yeah, quite a bit of working to do. So 2 of the 30 students chosen at random. Now, if I was going to draw a full probability tree, there'd be like 4 branches, wouldn't there? There'd be like French only, German only, French, German, none. Or neither. Okay, and then again there's going to be like 4 branches after this as well, but that's kind of long, and I don't need all that information. I'm not actually interested in this bit down here. I'm just interested in the French only and the German only branches, and then after that I'm only kind of interested in the 2 branches of the things I'm going to look at. Okay, so again, French only and German only and French only and German only here. Okay, so then if I want to have one of each, okay, 1 French only, 1 German only, I could get French only on the first go, and then I'd have to go German only after that, wouldn't I? Or I could go German only first and then French only. So they're the 2 routes through that I would need to have. Okay, so what is the probability then of French only and then German only? That's going to be equal. What's the probability of going down that branch there? Well, on the first selection, you've got 30 people to pick from, and there are 8 in the French only region. So that would be like 8 out of 30, wouldn't it? Okay, so 8 out of 30. And then in the second selection, if I've already picked 1, so I've only got 29 left to pick from. I haven't picked anyone yet from the German only region, so there must still be 11. So that would be 11 over 29 then, wouldn't it? Okay, and then for the other route, that's the probability of German only and then French only. So that's going the green route. So if I went the green route, German only on the first selection, I've got 30 students to pick, and I have got 11 German students, haven't I? So that would be 11 out of 30. And then on the second selection, French only, I've still got all my 8 French only students, but now I've only got 29 to pick from. So that's going to be 8 over 29. Okay, so then 8/30 times 11/29. That comes to 44 over 435. Okay, and then the other one's going to be the same, isn't it? Because the numerators are both the same. They're just inverted. They're just swapped around, aren't they? So that's going to be another 44 over 435. Okay, so then the probability then, one French only, one German only. That's going to be the two added together, isn't it? It's going to be the 44 over 435 plus the 44 over 435, which comes to 88 over 435, and that's going to be my final answer, 88 over 435. Okay, so like I say, there should be more branches to this. There should be another 2 there, and there should be another 2 there, but I'm kind of just ignoring them because I don't need that information. I'm just concentrating on the part of the diagram I do need, otherwise I'd be here all day drawing a massive spidery thing. Okay, and I don't want to do that. Right, I want to move on and do the rest of the paper. Let's move on and do the rest of the paper. Question 12. A solid metal sphere has mass 235 grams. The density of the metal is 7.78 grams per cubic centimeter. Show that the surface area of the sphere is 46.9 centimeters squared. Correct to 3 significant figures. You must show your working. And they've handily given us the formula for a sphere with radius r. Then the volume is 4/3 pi r cubed, and the surface area is 4 pi r squared. For some reason my pi's have come out as r's, so I'm just going to change those. Okay, so that's 4 pi r squared, and that's 4/3 pi r cubed. Actually, I don't know why it came out weird. Anyway, so let's break this down then. So we need to work out the surface area. So to find the surface area, we need the radius. How are we going to find the radius? Well, we know the mass and we know the density, so we can work out the volume. And once we know the volume, we can work backwards, work out the radius. And once we know the radius, we can work out the surface area. Easy squeezy. Let's start with the formula for density, mass, and volume. That's how it looks. So density equals mass over volume, isn't it? So, and we're trying to find, but is that what we're trying to find here? We've got mass, we've got density, we don't have volume here, but so we're kind of working backwards to find volume. So the mass is 235 grams. Density is 7.78 grams per cubic centimeter. Just when you're doing these compound units, just double check that they match up. These ones do, they're both in grams, but sometimes you need to change them. And we're trying to find volume here, aren't we? Okay, so cover up the thing I want to find. It's the V this time. So volume equals mass over density. So volume equals mass divided by density. Okay, and in this case, that is 235 divided by 7.78. Okay, so according to my calculator, 235 divided by 7.78, that comes out to be 30.2 something or others. So it had grams, I divided it by grams per cubic centimeters, I've got cubic centimeters then. Okay, so that's 30.2 cubic centimeters. Right, so we're looking good. We've got the volume now. So that's step 1 of the plan done. Step 2 of the plan is to find the radius now that we know the volume. Okay, so I'm going to start with that volume formula, that the volume of a sphere is equal to 4/3 pi r cubed, to try and work backwards to find the radius. Okay, so subbing in what we know that the volume is 30.2-ish. I'm keeping the stored value on my calculator so I can use that when I actually type it in. Okay, as that's equal to 4/3 pi r cubed. Now we're going to do some rearranging here. I'm going to cross multiply. Like the 3 will go up, the 4 will come down, and the pi will come down. Okay, does that make sense? So we're going to get 3 times 30.2 over 4 pi is equal to r cubed. Okay, so this is the time to start chucking that into the calculator. So I'm just going to take my previous answer, multiply it by 3, and then divide it by 4 and divide it by pi. Okay, that comes out to be 7.21. Now that's going to be r cubed. So then to find r, I'm going to have to cube root that, aren't I? So cube root of answer. And that comes out to be 1.93. Now my final answer needs to be like, so I'm just going to write that down. Again, I'm going to keep that in the calculator. So r equals 1.93. But I'm going to retain that number on my calculator for a bit longer. So r is 1.93. Okay, so that's good. So we've now done part 1 and 2 of our master plan. The last part is to then work out the surface area now that we know the radius. Okay, so now the surface area is going to be 4 pi r squared, where r is 1.93 then, isn't it? That's 4 times pi times 1.93 squared. Okay, now again I'm going to use my retained value in the calculator to do this. So I'm just going to square my answer first, and then I'm going to times it by 4 pi. And that comes out to be 46.9. And because radius was in centimeters, this is going to be centimeters squared, isn't it? Centimeters squared. Question 13. A straight line passes through the point 8, 1 and is perpendicular to the line y equals 4x minus 2. Find the equation of the line given your answer in the form of y equals mx plus c. Okay, so from the line y equals 4x minus 2, then our gradient, which I'm going to call m1, is 4 then, isn't it? Okay, so our line is perpendicular. In other words, m2, our gradient, is going to be minus 1 over m1, the negative reciprocal of the original gradient, so that's going to be minus a quarter. Okay, so I've got the gradient already of my new line. All I need to do now is to find c, the intercept, don't I? Okay, and to do that, I'm going to use this point up here that it passes through. Okay, so first off, I'm going to say equation is of form y equals minus a quarter of x plus c. So I've kind of created a partial equation by subbing in the m value I know of minus a quarter here, and that just leaves me the c value to find. And I'm going to use the point to find it now. So line passes through the point 8, 1. So subbing those values into the line, that means this is 8 is the x value and y is the 1 is the y value. So subbing in the y equals 1, and that is equal to minus a quarter lot of x, which is 8 plus c. And then what's that then? So minus a quarter lots of 8, that's minus 2. So I've got 1 equals minus 2 plus c. Adding 2 to both sides, you can see that c is equal to 3 then, isn't it? Okay. So now I've got the full equation. Therefore, equation is y equals a minus a quarter of x plus 3. Question 14. Y is inversely proportional to the square root of x. Y is 5 when x is 36. Part A says find a formula linking x and y. Okay, well, we're told that y is inversely proportional to the square root of x. We're going to use that bit first. So y is little fishy, proportional symbol, is equal to 1 over root x. Y is proportional or inversely proportional to the root of x. Okay. Now replacing the sign of proportionality with equals k, I'm going to get y equals k over root x. Okay, k is the constant of proportionality, which we need to find, and we're going to find it using this pair of values here that go together. Okay, when y is 5, x is 36. So we're going to be using that. When y equals 5, x is 36. I'm going to sub those in and then the only thing we won't know in what we get is k, and then we can then find it. So 5 equals k over root 36. The square root of 36, that's 6. So 5 equals k over 6, and then cross multiply, and then that implies that k is equal to 30. Okay, so therefore formula is, and then the complete formula is y is equal to k, which we know is now known as 30 over the root of x. Okay, so that's my complete formula. Okay, and then part B says find the value of x when y is 20. So now we need to sub into our formula and find x given y. It's a little bit annoying because we've got a formula in terms of y, and then we want to find x. So probably the first thing to do would be to rearrange and make x a subject. I think I might do that. So y equals 30 over root x. So let's cross multiply these and say that root x equals 30 over y. And then squaring both sides, I'm going to get x equals 30 squared, which is 900 over y squared. So when y equals 20 then x is going to be 900 divided by 20 squared, isn't it? Or 9 divided, I know that 20 squared is 400. 9 divided by 400, what's that? That is 2.25 apparently. 2.25, so that's my solution, 2.25. Okay. 15a, show that the equation x cubed minus 5x minus 1 equals 0 has a solution between x is 2 and x is 3. Okay. What I'm going to do is I'm just going to sub in each one of those into the equation and see what I get. So when x is 2, then x cubed is going to be 2 cubed minus 5 lots of 2 minus 1. What's that equal to? That equals to 8 minus 10 minus 1, which is equal to minus 3. Okay, and then when x equals 3, then I've got 3 cubed minus 5 lots of 3 minus 1. That's equal to 27 minus 15 minus 1. And that is 27, what's that, 12, 11, minus, positive 11? Positive 11, okay? So this equation has gone from being negative to being positive. If that's the case, so like if you imagine you've got like your x-axis. Now at the point x is 2, it's down here, and at the point x equals 3, it's up here. Then somewhere between 2 and 3, this graph must have crossed the x-axis. Okay? In other words, it must have been momentarily 0 somewhere between 2 and 3. Okay? So that's what we're going to just write that down in words. That says equation is negative at x equals 2 and positive at x equals 3. I'm going to say that cubic curves are continuous. They don't have any breaks, do they? Continuous, so it must have crossed the x-axis between 2 and 3. Part B says find the solution correct to one decimal place. You must show your working. Okay, so in order to do this, I'm going to create a little table. Okay, so 3 columns. So I'm going to have my value of x, and then my value of the formula, and whether it's too high or too low. Okay, so x cubed minus 5x minus 1. So I suppose I can just put sign there, can't I? Positive or negative. Okay, so because that way it passes over 0, it's going to change from positive to negative. So I can use that to kind of hunt my value. Okay, so we already know it's between 2 and 3. Now I could just kind of do trial and improvement to find it, but I'm going to just use a handy function on the calculator to do it. It's the same button we use for like drawing graphs and doing a table of values. So if you go to the table function on your calculator, if you've got a Casio, then I'm going to put the function in for the cubic, which is x cubed minus 5x. You can use the alpha key to access that, x minus 1. Okay, so that's my function. Now, no g of x required. Now my start value is going to be at 2. That's the where it was negative, and my end value is going to be at 3. Now I'm going to change the step to 0.1 because I want to see all the values between 2 and 3, 2.1, 2.2, 2.3, and so on. Okay. Now if I generate the table now, you can see I've got values for 2.1, 2.2, and so on. And the first few are negative. Where does it flip over? It flips over between 2.3 and 2.4. At 2.3 it's still negative, and 2.4 it becomes positive. Okay. Now, so rather than doing a trial improvement, I'm just going to pull out those two values and put those down. So when x is 2.3, I know that it is minus 0.333, which is negative. And then at 2.4, it becomes 0.824, which is positive. Okay, so we had it pinned initially between 2 and 3, and now I've got it pinned between 2.3 and 2.4. So the final thing I want to check then is the mid value of those. So what's halfway between 2.3 and 2.4? It's going to be 2.35. Okay, so what's halfway between 2.35? I want to do a test on 2.35. Now I could just type that all in again. I might just use the table function again. So if I press AC equals, and then just change the range from 2.3 to 2.4, going up in steps of 0.01. It's probably more than I need, so I'm just going to scoot down to 2.35 and write that one down. So that is 0.2278. 0.2278, which is positive. Okay, now that means that it, we knew it crossed somewhere between like 2.3 and 2.4, so we knew it was negative at this point and positive over here, but now we also know that it is positive at 2.35. So that means that the point where it crossed over was to the left of 2.35 somewhere, which kind of means that it's closer to 2.3 than it is to 2.4. Okay, so this tells me by testing the halfway point, what we're doing is seeing, well, does that answer round down to 2.3 or does it round up to 2.4? So this is enough to tell me that that it's going to be 2.3 then is my final answer. This is the one I'm going to go for. Okay, so 2.3 is the correct solution. So with these questions, pin it between two values to one decimal place, test the mid value of those two values to decide which way you're going to round it. So for me, I tested the mid value, I found it was positive, which means I need to round down to the lower one and give 2.3 as my final answer. Question 16, the following kinematics formulas may be used in this question. So we've got v equals u plus at, s equals ut plus half at squared, and v squared equals u squared plus 2as. Now it says we may need them, doesn't mean we need to use all three. Okay, I think we have to pick, don't we? So the initial velocity of a particle is 20 meters per second, the acceleration of the particle is minus 8 meters per second squared, and after t seconds the particle has travelled 25 meters. Show that 4t squared minus 20t is equal to 25. Okay, so which of the equations is going to deliver me that? Which one has got t squared in it and t? It's going to be this one, isn't it? Oops. I think we're going to be using this one, aren't we? Okay, that's got the t squared in it, so I think that's the one that's going to give us that quadratic. Okay, so that's the one I'm going to sub into. So let's see what we've got. S equals ut plus half at squared. So subbing in what we know, what do we know? The initial velocity, that is u, isn't it? The initial velocity is 20. Now we call that one u. Okay, so that is going to go here, in here. Okay, and then the acceleration of the particle is minus 8. That is my a. So a acceleration, that goes in here. And after t seconds, the particle has traveled 25 meters. That is our distance, isn't it? Which in SUVAT formulas is denoted by s. So this is our s. Okay, and that then needs to go here. Okay, so then the only thing we don't know there is t, so that's why we end up with an equation in t down here then. So let's sub in what we know. So 25 is equal to u, which is 20 lots of t, plus a half times minus 8 times t squared. Okay, so let's just tidy that up a little bit. Now we've got everything on one side equal to 0. Okay, so let's just rearrange. So then just simplifying that a little bit, 25 equals 20t. Half of minus 8, that's minus 4t squared then, isn't it? Okay, and then bring in everything over to one side, so add in 4t squared and taking away 20t from both sides. I'm going to end up with 4t squared minus 20t plus 25 equals 0 as required. Okay, so that worked. And then solve 4t squared equals 20t plus 25 equals 0. So now we have to go on and solve it. Okay, so solving a quadratic equation. Can we factorize it first? That would be nice if we could, because then I won't have to use the formula. So 4t squared minus 20t plus 25. Okay, if we can factorize it, then we're going to have factor pairs of 25, aren't we? So what are the factor pairs of 25? So what are the factor pairs of 25? You've got 1 and 25, or you've got 5 and 5, haven't you? They're the only options you got there. Are any of those going to deliver me minus 20 in the middle? Well, maybe, because I remember I've got a 4 at the beginning as well, so it's not quite as simple as that as well, because we could have a 4t and a t, or we could have a 2t and a t, 2t and a 2t there, haven't we? So is there a way of putting over 5 and 5, or a 1 and a 25 in here and deliver me 20 in the middle? It's not going to work with 4t and t. I was just trying putting like 5 and 5 in here, or 25 and 1, and it doesn't work out. But I'm going to try instead 2t and 2t. So 2t and 2t, and see if that works instead. So yeah, actually that might work, mightn't it? If I put the 5 in and the 5, and then make them both negative, then that's going to give me the positive 25 at the end, when negative 5 times negative 5 is positive 25. And the negative 5 times 2t is going to be negative 10 twice, isn't it? So that does seem to work. I'm happy with that. So 2t minus 5 times 2t minus 5 is equal to 0. Should really do it this way around, I suppose. So that implies that that's equal to 0. Which you can see is a square, isn't it? That's actually 2t minus 5 all squared equals 0. Okay. So then what are the solutions? It's a repeated root, isn't it? So there's only one solution here. That's going to be equal to 0 when 2t minus 5 is equal to 0. So that's going to give me 2t is 5. Or t is equal to 5 over 2, or a half, isn't it? Or 2.5, sorry. So t equals 5 over 2. It's just a repeated root. Question C. Show that the particle is stationary when it has travelled 25 meters. Okay. Now again, we've got these three SUVAT formulas that we can pick from, but which one we're going to use? Okay, well, let's just write down the 5 things. Suvat. And think about which one we've got and which one we need to find. Okay, so S, that's the distance traveled. Well, that's given in the question. It's 25 meters. U is the starting velocity. That was given at the beginning of the question as 20 meters per second. And then V, that's the end velocity. That's what we're trying to find. We want to try and show that that's 0, actually, don't we? So it's stationary. And then A, we were given that in the original question. It's minus 8 meters per second. And T, not given in the question, not given in, in fact, we don't even need it, do we? We're not interested in time, so that's the one we don't need. So in terms of the Suvat formulas, we don't need those two because they've got T in it. We're going to be using this one, v squared equals u squared plus 2as. So let's write the formula down. V squared equals u squared plus 2as. Sub in what we know. U is 20. So it's 20 squared plus 2 lots of a, which is minus 8, plus s, which we know is 25. So what's that then? Just double check that on the calculator. 20 squared plus 2 times negative 8 times 25. That's 0. So that's it then, isn't it? We can say that the velocity is 0, which implies stationary. Okay. Question 17. The diagram shows a pyramid A, B, C, D, E. The pyramid has a square horizontal base A, B, C, D with sides 5.6. The vertex E is vertically above the center O of the base, and the height OE of the pyramid is 6.8 centimeters. Calculate the surface area of the pyramid. You must show your working. Okay, well, the pyramid's surface area is going to be made up of the base, which is a square, plus the 4 triangular surfaces, triangular faces of the pyramid, isn't it? Okay, now the base is not going to be any problem, is it? So pyramid base, so the base is just a rectangle, so area base equals length times width, which is 5.6 times 5.6. That is going to be 5.6 times 5.6 is 31.36. You know, in these harder questions, even if you don't know what to do, there's always easy marks to get on them. So, you know, working out the area of a rectangle, not too difficult there for probably one of the marks available for this question. But we need to find the triangle next, don't we? So what about the triangle? Now, for the triangular faces, area of triangle, well, that's half base times height, isn't it? Okay. So the base is no problem. If we have a look, we know the base is 5.6. What about the height of the triangle? Now the height of this would actually be, I suppose if we got a ruler out. So like say if we took the center point of this face and drew a line from the tip down to that point, that's actually the line we're trying to find, isn't it? That's the length of well, that's the height of this triangle, because it's kind of, you know, if it was laying flat, that would be the height there, wouldn't it? So that is going to be our h that we're trying to find. If we know that, then we've got the base, we can find the area of that face. Okay, but how are we going to do that? Well, if I put another line in here, look, then this should be a right angle triangle here. So if I say that's M, the midpoint of BC, then triangle OEM. So let's just quickly draw that triangle by itself. So that is EOM. Now we know that E to O is 6.8. Okay. This is going to be our h that we're trying to find, and then what's that distance there? Well, that distance from O to M, that's going to be half of AB, really, isn't it? So, you know, because it's half half that distance, and that's the same as that distance. So the distance from here to here is the same as this one, and O to M is half of it, isn't it? So that's going to be 5.6 divided by 2. 5.6 divided by 2. What's that? 5.6 divided by 2. That's 2.8. So that side is 2.8. So then I can use Pythagoras theorem then, can't I, to find h? Because this is a because this is a right angled triangle of which I know two shorter sides and want the longest side. So then h squared is going to be 6.8 squared plus 2.8 squared then, isn't it? Okay, so then what's that? Root 6.8 squared plus 2.8 squared, all square rooted. That comes out to be about 7.35-ish. Okay, I'm going to leave the, so that's h. So h is about 7.35. I'm going to leave the full calculator display on my calculator because I'm going to use it in a second. So then the area of that triangular face is going to be a half times the base, which was 5.6 times the height, which I now know is 7.35. Okay, so what does that come out to be? 7.35 is already on the screen, so times that by 5.6 times 0.5. That comes out to be 20.6. And that's going to be in centimeters squared, isn't it? So then the surface area of the pyramid is going to be the base area plus 4 times the triangles, isn't it? Okay, so it's going to be the 31.36 that I found plus 4 times the 20.6 that I found. Okay, so then multiplying 20.6, what my calculator display, by 4, and then adding on the base, which was 31.36. That comes out to be 113.7, which I'm going to round off to 114 centimeters squared. 3 significant figures seems appropriate. Okay, and that's going to be my final answer, 114 square centimeters. Question 18, rearrange this formula to make y the subject. Okay, now I can see y appearing in 2 places here, so it's not going to be a straightforward rearrangement. It means I'm going to have to do some factorizing at some point. Okay, but first off, I've got y down there at the bottom. I don't really like that. Let's cross multiply. So multiplying both sides by y and by 2 will move those things there and there. Okay, so that's going to give me 2 lots of 5y plus 2 is equal to y lots of 3t minus 7. Okay, so removing the brackets, that's 10y plus 4 equals 3ty minus 7y. Oops. Okay, so I've got 3 terms with y in and a 4. Okay, so what I'm going to do is I'm going to get everything with y in on one side. Probably the easiest thing is to move the 10y over to join the other 2 over there. Okay, that will keep things positive as well. So I'm going to leave the 4 where it is. I'm going to subtract y from both sides. So 4 equals 3ty. That's going to be minus 17y then, isn't it? Okay. Now, like I said before, because we've got y in more than one place and it's kind of got things multiplied by it, the trick now is to factorize it out of the 2 terms to get y by itself. So if I factorize y out of 3ty minus 17y, I'm going to get 3t minus 17 inside the bracket like that, and that's going to be equal to 4. And now all I need to do then is divide both sides by 3t minus 17, and that's going to give me y is equal to 4 over 3t minus 17, which I'm just going to flip around for my final answer. Y equals 4 over 3t minus 17. Okay, 5 marks for that. That's not too bad, is it? Okay, all done. You can find more exam question compilations over here, For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.